Hello guys, good evening to all of you. Am I audible to you? Okay. So just wait for 1 or 2 minutes. Let them to connect everyone. Let them to join. Then we start our class. Yes, good evening to all of you. Okay. So just to start the class. So in last class we discussed about sphericity and some small discussion on screening. Okay, and screen size. So now today we study first mix size analysis, then we continue, then we take screening. Okay. So write first mix size analysis. So there are two types of analysis. One is average size, another is the mix size analysis. So is there any doubt in the last class? Okay. Okay, I will again start the screen. Okay, screening. Okay, the weightage for this subject is 4 marks and this subject is too much scoring. So let us first take mix size analysis, then we can take the screening and we'll discuss. Okay, so right, mix size analysis. So what is mix size analysis? So right, we want to prove this expression, specific surface area equal to 6 by 5 rho p summation xi by dpi. This we want to derive these expressions. Why I want to go for derivations? Because some internal correlations questions will be asked in the GATE exam, so that its derivation is important. So let us consider for a sample I. Let's write for a sample I. The total volume of particles is represented as total volume of particle, that is represented as Vi equal to Mi by rho pi. Okay. The total volume of the particle is represented as total volume of the particle for a sample I equal to Vi equal to Mi by rho p I. Is it clear to all of you? Yes or no? Okay. If the volume of single particle is Vp, see here, if the volume of single particle is Vp, okay, single particle volume. So can anyone tell me what will be the total number of particles in the sample I? Anyone? Did you understand the questions what I asked? If total volume of particles in a sample Vi, that is equal volume is Vi, and if the volume of single particle is Vp, so number of particles will be what? Obviously, it will be Vi by Vp. Yes or no? Okay. So total number of particles for sample I equal to Vi by Vp. Is it clear? So this is represented as Ni. Okay. Total number of particles for a sample I. So this Ni equal to Vi by Vp. Is it clear to all of you? Here we need to derive these expressions. Sample is the name of the sample, okay, name of the sample, and in that sample it is a mixture of many species in that sample. Okay, I'm telling that I is the name of that sample. Okay, what is a someone is saying what is ASS? ASS means specific surface area. Specific surface area we want to derive for mixed size analysis. Okay, so this is the one of the concept, the total number of particles for a sample I equal to Vi by Vp. I hope this is clear to all of you. Please note down this. Is it clear to all of you? Or if you have any doubt till now? Okay, so please note down this, or if you already noted, just inform me so that I will move to the next slide. Actually, this topic is under size analysis. Okay, no, yes, I is for a particular sample, it is not for a single particle, it is for a sample. Here I for a sample I, it is written na, for a sample I, the name of the sample is I. Is it clear? It is a mixed size analysis. Okay, so why it is mixed size? Because why telling it is mixed size? Because it is a combination of many size. Okay, different types of particles are there, and its size are different. So how can you take its uh, how can you calculate its specific area or its specific surface area? This is the concept for this. Is it clear? Somalia Mukherjee, is it clear to all of you? This is very simple. For a sample I, the total volume of the particle is Vi, and it's really obviously it will be Mi by rho pi. So if the volume of the single particle is Vp, the total number of particles for a sample I, that is Ni equal to Vi by Vp. So here Ni equal to its particles are uniform. If you want to write, someone is saying why it's so. If you have doubt, so write one more point, one more line for that. Let us consider a sample of uniform size. Okay. There is an assumption for that. Let us consider, if you want to write, you can write because someone have doubts for that. Let us consider a sample of uniform size of diameter dp, mass m, density rho. Okay, density rho. Okay, if you have doubt in that parts, you can write also in this form now. Let us consider a sample of uniform size of diameter dp, mass m, density rho. Then how can you define the volume of the particle? The volume of particles will be what? If you have doubt on that part, you can consider also this. The volume of the particle will be what? Mass upon density? Yes or no? Yes or no? Yes. Volume of the particle will be mass upon density. If you have confusion on that part, Ni or in terms of I, sample I or other thing, consider this part. The volume of particles will be m by rho. Okay. If I am saying that if Vp is the volume of single particle, try to understand the concept. If Vp is the volume of single particle, okay. So what is the number of particles in the sample? What is the number of particles in the sample? The number of particles in the sample, I will be what? Ni equal to V by Vp, yes or no? Just tell me. Yes or no? Is it clear? Ni equal to V by Vp. So can I write this Ni equal to Vi by Vp? Yes or no? Is there any doubt? Here I represents a sample, particular sample for a sample I. Now it is clear to all of you. Sai Sudarshan. Now it is clear because for you that I have considered this concept. This means I changed that its modification. So Ni equal to Vi by Vp. Okay. So now this is what? Volume of the particles. So we can write it is for sample I. So it is Vi. So Vi equal to what? Mi by rho pi. We can write no problem. Mi by rho pi. So not we can write. Can I write this? Ni equal to, in place of Vpi, we can write Mi by rho pi into Vp. Yes or no? Just tell me whether it is clear or not. Till now it is clear. Just I replace the value of Vi equal to Mi by rho P I. Okay. If I'm telling that if the surface area of single particle is the surface area of single particle is Sp. So what is the total area? What is the total surface area of what is the total surface area in a sample I? Anyone? Very good. Very good, Somalia. Yes. So yes, total surface area in sample I will be what? Obviously, it will be Ni into Sp. Is it? Ni into Sp. So this total surface area this Ai, okay, it is represented as Ai equal to Ni into Sp. So in place of Ni, can I write Mi rho P Vp into Sp? Yes or no? Just I have put the value of Ni equal to Mi by rho P into Vp. Is it clear? Yes or no? Is it clear to all of you? So here what we got, it is Mi Sp by rho P into Vp. So we want to introduce the concept of sphericity here. So we know that phi s equal to 6 by dp Sp by Vp. Yes or no? Is it? 6 by dp Sp by Vp. We already discussed in the last class. Sphericity equal to 6 by dp Sp by Vp. So why I am doing this? We want to introduce the concept of sphericity in total surface area. So from here, you will get the value of Sp by Vp equal to 6 by phi s dp. Is it clear? Or is there any doubt? Please note down this. Is it clear to all of you? Please cooperate with me. So Sp by Vp equal to 6 by phi s dp. So please note down this. So this is for a particular sample I. So we can write it is 6 by phi s dpi. No problem. I is your sample. So please note down this, or if you already noted, so just inform me so that I will move to the next slide. Okay. Now, so here you can write Ai equal to 6 mi by rho pi phi s, or we can write phi si for a sample I, no problem, into dpi. Is it clear? So ai equal to 6 into mi by rho pi into phi s into dpi. I hope this is clear to all of you. So this we can write from the previous expressions. Just I have substituted the value of sp by vp here. Okay, 6 by phi s into dpi. 6 by phi s dpi. Is it clear? So here we can write it is ai equal to 6 mi by rho pi phi s into dpi. So this is for a sample I. So if I want to find the total surface area of entire mixture, okay, if I want to find the total surface area of entire mixture, so this AS means total surface area will be represented as summation AI, yes or no? Here AS is the total surface area of entire mixture. We can write or not? AS equal to summation AI. So again, so I will explain, I will repeat this, but see here, we can write or not, where I varies from 1 to n. Is it? Yes or no? So this AS equal to what? Summation 6 mi rho pi phi s dpi. Is it? Where I varies from 1 to n. Yes, yes. Here dpi is the equivalent diameter, no problem. Is it clear? Yes or no? So this is the total surface area of the entire mixture. So here you can take common 6 rho pi phi s summation mi by dpi. You can write or not? So obviously rho p equal to rho pi equal to rho. Is it? We can write or not? Just tell me whether it is clear or not, this part. So this is the total space, total surface area of the entire mixture. Now tell me, if you want to find the total specific surface area of entire mixture, what we have to do? If you want to find the specific term, what is the concept? I already discussed in case of thermodynamics. So we have to divide by total mass. Is it? Divide by total mass. Yes. So this AS is equal to AS by MT. Okay. Total mass this can be written as 6 by rho p phi s summation xi by dpi. Yes or no? If you divide mi by total mi by total mass, here xi equal to mi by mt. Mass of sample I divided by total mass of the entire mixture. So we can you can replace mi by mt equal to xi. Is it clear? Yes or no? Just tell me. So this is the thing we want to prove. We want to derive this. So your standard equations is AASS means specific surface area 6 by phi s rho p summation I equal to 1 to n xi by dpi. I hope this is clear to all of you. So again, I'm repeating this. So someone have asked that one. Okay. So suppose let us consider a sample of uniform size of diameter dp, where I is the sample, so it's really dpi, and mass m, density rho. So vi is the volume of the particles. So it's mi equal to rho pi, and vp is the volume of single particle. The number of particle in the sample will be what? Ni equal to V by Vp, or obviously it is Vi by Vp. Is it clear? Vi by Vp. So then we will write Ni equal to Mi by rho pi into Vp. If the surface area of single particle is Sp, then total surface area in the sample I equal to Ni into Sp. So obviously Ai equal to Ni into Sp, total surface area in a sample I, Ai equal to Ni into Sp. So obviously this Ni written as Mi by rho p into Vp. Then someone is saying what is difference between specific surface area and normal? Here, for it is a surface area. Okay. You know what is surface area? Or what is specific surface area? Its name is specific surface area. Specific surface area means surface area divided upon total mass. Okay. Why here specific surface area is important? If you consider the size reduction parts, so okay. So basically, size reduction is done means size reduction means breaking of the particles. So where surface area is very important to consider this. Okay, for the crushing rules. Okay, now it is clear. So this 6 by 5s dpi, and now here the case ai equal to 6 mi by rho pi 5s into dpi, and the total surface area of the entire mixture equal to as equal to summation I equal to 1 to n ai, and obviously you have put the value of ai here, and we want the concept of total specific surface area. So obviously it is total surface area by mass. So obviously here total specific surface area equal to 6 by 5s rho p summation xi by dpi. I hope this is clear to all of you. Just tell me whether it is clear or not. So we have to always take this average dpi, means average size of the particle. Okay. So Now it is clear to all of you this part. I'm asking from everyone. Is it clear? So please note down this. Or if you have any doubt, just you can now ask me. I hope this is clear to all of you. So please note down this, or if you already noted, just tell me. Yes, someone is saying DPI bar. So right, DPI here I'm considering its topic name is average size analysis. So it is mixed size analysis. So under average size analysis means size analysis. So there is a average mixed size analysis. Okay, so DPI bar equal to DP max of I plus DP minimum size of sample of I, minimum size in a sample of I divided by 2. We always take its average diameter. Now it is clear. So if it is clear, is it clear? Someone is saying DPI bar. I have written na, here it is DPI. So it is DPI bar. Actually, it is average diameter of the particle, average diameter, okay, in the sample I. So obviously it is DPI bar. If it is a mixture, it is obviously it is a mixture of it is a mixture na, because it is a mixed size analysis. So we always take DPI bar equal to DP maximum for sample I or DP minimum for sample I and divided by 2. We will always take average size. Is it? We always take average size for that. If I discuss one question, this will be clear. Here, see, why we are doing summation? We are taking summation because we consider for a sample I na, but in an entire mixture there are many sample na. So that's why I have taken the summations. The average size will happen for each species, right? Yes, yes, yes. Oh, yes, these are all average. Yes, yes. In previous size analysis, always these are all average size. Okay, DPI bar. It is DPI bar. In each and everything, we always consider average size. Okay. Yes, average size for the sample I. Is it clear? I hope this is clear to all of you. Somalia Mukherjee, Udit, Vishnupriya, I'm asking from everyone. Is it clear to all of you? Or is there any doubt? So please note down this, or if you already noted, just tell me. So we'll discuss one question. Can I move to the next slide? So try to solve this question. I'm giving you one question. In a solid catalytic industry, in a solid catalytic industry, very fine size of solid particle of magnesium having density 1.2 gram per cc, and its value is given phi equal to 0.5, means phi s equal to 0.5. Calculate the total specific surface area calculate the total specific surface area and shorter mean diameter and shorter mean diameter of the mixture. This question is came when the gate is subjective. So, but this is a very good question. And shorter mean diameter of the mixture having following particle size analysis. Having following particle size analysis. All data are given. So here it is cm centimeter. So dpi bar is given. It is 0.987. mi is 0.09. xi is 0.026 and xi by dp is its value are given, no problem. Zero 0.568, mi equal to 0.12, xi equal to 0.35, and here it is 0.0616. First, we will try to find this. Okay. Zero 0.346, 0.23 to 0.067. Now it is 0.380. Its MI value is 0.31, and now it is 0.09. 0.206, it's 0.11, it's 0.032. Here it will be 0.105, and it is 2.56, it is 0.748. These are the data given. Now try to find out its total specific surface area, means ASS, and shorter mean diameter. And shorter mean diameter means volume surface mean diameter. Yes, it is 0.748. If you will find, you will get the corresponding value xi by dpi bar, and it is 0.026 and 0.0616 and 0.1936. I'm just rounding off, and 0.236, and it will be 0.155, and it will be 7.12. Try to check Somalia once more time and answer. Yes, you are closer to the answer, but it is, I think, just try to solve. Yes, many of them are given the answer. Yes, Somalia Mitra, shorter mean diameter is 0.12, 0.128 centimeter. And Sai Sudarshan, you are right. Uh, ASS will be 77.95. I mean, it is approximately equal to 78. Yes, no problem. Yes, 77.98, 77.95. It depends upon your rounding up, but we'll get the answer. Aditi Mandal, your shorter mean diameter is not right. Shorter mean diameter will be ds bar equal to 0.18, 0.128 centimeter. It is nothing, no, it is 1 by summation of xi dpi. We have calculated already xi dpi. Just do summation and just put in reciprocal 1 by this. Yes, shorter mean diameter is 0.128. Correct, Kushal Narottam. Many of them are getting the answer. Somalia, are you getting the ASS? It's 77.98 or 78, closer to 78. All of you are getting the answer of ASS equal to in a range of 77 to 78. Yes or no? Okay. Shorter mean diameter equal to 0.128. Okay. And its ASS will be in a range of ASS answer will be in a range of 77 to 78, and DS bar equal to 0.128. Now it is clear to all of you. We are getting or not? Is there need to solve this question or it is solved? Yes, correct. No problem. Your answer in a range of 77 to 78. If you round up this, so we'll get the value of 78. Nearest integer. So I hope this is clear to all of you. So is it clear to all of you? You can solve this question now. Is there need to solve this question? Yes, okay. So next we move to the screening analysis. We already started in the last class. Screening. What happens, Anmugam? Your answer are correct, no problem. Your answers are correct. So that's why I'm telling now it's a range value. ASS will be 77 to 78, and shorter mean diameter will be 0.128. So that's right. We already discussed representation of mass number. What is mass? Means number of holes or openings per linear inch. Okay. We also discussed negatives and indicates the particle have passed through the mass screen, and positive sign means that materials have written on the screen. Okay. And then also I discussed the Taylor screen, the ratio of AI by AI plus 1 equal to 2 and Li by Li plus 1 equal to root 2. I discussed all these things. Now it is clear, because it is assumed that in Taylor standard screen, so the geometry for that particular opening will be square shape. Okay, the shape of the opening will be square, so obviously the ratio of actual dimension to the next is actual dimensions to that of the next screen means Li by Li plus 1 equal to root 2. I already discussed this thing, or I also discussed the mass is the number of openings or holes per linear inch. Is it clear? Yes or no? Suppose I'm asking one thing, for a particular mass, its size will be, it is defined that minus 150 to plus 170. And I asked one thing, calculate dpi bar. What is the value of this? Means what is the average size of the particle here? Anyone? What is the average size of the particle here? Very good. D170 plus D150 by 2. So it is 150 plus 170 by 2. We cannot put here minus 150 plus 170 by 2. Is it? Okay. Because negative indicates, I also discussed now, negative indicates the particle have passed through the screen, and positive sign indicates the material have been retained in that screen. Is it clear? Is this concept is clear? So its answer will be 150 plus 170 by 2. So obviously it is 160. Yes, 160. Sai Sudarshan, your doubt is clear or not? Because you said 10, because you already taken minus value. So there is a chance of doing mistake here. So always remember, negative sign indicates that the particle have passed through the screen, and positive sign indicates that materials have been retained on that screen. Okay. So next, write screening. Yes, yes. 150 and 170 is the mass number. Next, write screening. Yes, yes. Undersize and oversize. But for a particular mass, there is an undersize and oversize. Okay. Negative and positive. For a particular mass, there is an undersize and oversize. So now write screening. This will be more clear here. So what is screening? It is the method of separating the particles. This is an important topic also. Sometimes the questions may ask from this topic. It is the method of separating the particles it is the method of separating the particles according to their size, according to their size in industrial screening, according to their sizes. Okay, this is the thing. It is the method of separating the particles according to their sizes. So now next point in you can write in industrial screening. The solids are dropped on the screen surface. Solids are dropped on the screen surface. Okay, the undersize, then undersize, then undersize fine particles are passed through the undersized fine particles are passed through the screen and oversize do not. And oversize means do not means oversize retained on that screen. Undersize will pass from that screen, or oversize will retain on that screen. So is it clear? So this is the thing we are doing in screening. It is the method of separating the particles according to their sizes. So tell me whether it is clear or not. It is clear to all of you? There are many type of screenings. Okay, one is shaking, another is vibrating screen, shaking screen. Okay, so I hope this is clear to all of you. Can I move to next slide? Sir, could you elaborate the industrial screening? Actually, industrial screenings, actually I will give the name of that screen. Actually, there are many type of screening points are there. One is grizzlies, tromol, vibrating screen, shaking screen. Okay, so there are many type of screen, but in basically in screening, what we do in general method, we have to separate the particles according to their sizes. Okay, means larger particle will retain on that surface, they will not pass from that screen size, and undersized particle means small size, very fine size particle will pass through that screen. Is it clear? Udit, is it clear? So next slide, material valence on the screen. Suppose this is a screen. Okay. These are different masses. So obviously there is a feed. It is a mixture of A plus B, means in feed there will be undersize and oversize. So A is here, suppose oversize, and B is undersize. Okay. So obviously we have overflow rate and underflow rate. So D is overflow rate and W is underflow rate. Underflow rate. And F is the feed rate. This is the F. So F is the feed rate. Now it is clear to all of you. This picture is clear. Please cooperate with me. If XF, XD, XW are the mass, are the, it is defined that are the mass fractions of oversized materials in the feed in overflow and underflow. That is clear to all of you. It is defined that if XF, XD and XW are the mass fractions of oversized material in the feed, overflow and underflow. Is it clear? You are not responding. So how can I know that you are understanding or not? Hello, am I audible to you? Okay. So if XFs are the thing, oversize means the larger size of the particles which are not passing through a particular screen size. Or undersize of the particle means the particle of the size of the particles which are just passing through the mass screen. Obviously, there will be a flow rate or not. Obviously, if particles are passing through a mass screen, so there will be a flow rate. If the particles are passing from the screen size, means they are undersized particles. So they have, so we are declared that there have, yes, there is a flow rate. Okay, so there will be underflow rate for that. And if particles on the retain on that, so there will be a overflow rate. Yes or no? So this is the meaning of this. If particles are passing through a particular screen size, so there will be a flow rate now. So tell me, what is this? 1 minus XF, 1 minus XW, sorry, 1 minus XD, and 1 minus XW is what? Anyone? Yes. Mass fraction of particle, mass fraction of undersized material. Yes, very good. So mass fraction of, just write mass fraction of undersized material in the feed, overflow and underflow. Notice clear to all of you respectively. Yes or no? Yes. I hope this is clear to all of you. Is it clear? Is there any doubt till now? Or it is clear to all of you? No doubt. So obviously, if there is a screen, then there will be their performance will be measured by some parameter. Yes or no? If there is a screen, everyone has its performance, is had its own performance. Yes or no? So next, right, screen effectiveness. Next, right, screen effectiveness. Please note down this, or if you already noted, so just tell me. So I move to the next slide. Screen effectiveness. So what is screen effectiveness? You can write, it is the measure of success of screen. It is the measure of success of screen in closely separating the materials, in closely separating the materials into oversize and undersize into A and B, or we can write into oversize and undersize. It is the measure of success of the screen in closely separating the materials into A and B, or oversize and undersize. Notice clear to all of you? Tell me whether it is clear or not. So if I define effectiveness of screen, if I define effectiveness of screen, effectiveness of screen based on oversize. If I define effectiveness of the screen based on oversize, so what will be its answer? Means effectiveness A represented as E, screen effectiveness. Okay, so it is oversized. So A is here oversized and B is undersized. So EA equal to what? Can I write? amount of effectiveness of screen on the oversize material. Can I write amount of materials oversize in D divided by amount of oversize in F? Yes or no? So mathematically you can write, sir, it is better to write material balance than screen effectiveness. Okay, no problem. No, if you do, okay. So, so this is the thing. So if you do material balance here, what is this? F equal to D plus W, yes or no? And it will be F into XF, D into XT plus W into XW, yes or no? Based on oversize, is it? Hmm. So if I will just I have to finish the effectiveness factor, then I will write material balance on that. Okay, is it? Are you agree with this? Are you agree with this statement? So I want to try to write this effectiveness based on our size. So it is uh, D into XT divided by F into XF. Okay, so just write this effectiveness based on our size. So D into XT divided by F into XF. So can anyone tell me effectiveness based on undersize? Yes, effectiveness based on undersize will be what? D into, sorry, no, sorry, it is not, no, means undersize and underflow, no. So it will be EB equal to W into 1 minus XW divided by F into 1 minus XF. Please note down this. Yes, this is the thing I have written here. EB equal to W by F, means W into 1 minus XW divided by F into 1 minus XF. Now it is clear to, now it is clear to all of you? Yes or no? So please note down this. Please note down this, or if you already noted, just tell me. So this is the effectiveness based on oversize, and this is the effectiveness based on undersize. Okay. Now I'm going to ask one question. What is the overall effectiveness? What is the overall effectiveness of the screen? Yes, it is EA into EB. Multiply both. Okay. Okay. So just next write overall effectiveness of the screen. Overall effectiveness of the screen, that is E equal to EA into EB. And from here we will get one result. What is EA? That is D into XD divided by F into XF. And what is EB? That is W by F into 1 minus XW divided by 1 minus XF. So I hope this is clear to all of you. This is the overall effectiveness of the screen. So obviously the performance of a screen is measured by effectiveness. So that's why it is known as screen effectiveness. It is a measure of success of the screen in closely separating the materials into oversize and undersize. So it is a measure of success of the screen in a closely separating the materials into A and B, or oversize or undersize. So now it is clear to all of you. Now it is clear to all of you. I'm asking from everyone. Is it clear? Okay. Okay. Now we do a material balance on this screen. Okay. So now we do material balance on this screen because someone is asked to do the material balance. So if you do the material balance, if you do the overall balance on the screen, so this is the screen where that, yes, this is the screen. If you do the overall balance, so it will be F equal to D plus W, or balance based on this is the overall balance and this is the material balance, means component balance. So F equal to D plus W, or F into XF equal to D into XD plus W into XW. This is for A. Okay. This is for A, means A is here oversize. Is it clear? Yes or no? So this is the diagram here. So I want to write directly from here F equal to D plus W and F for A. F into XF equal to D into XT plus W into XW. So I want to find a ratio of D by F. Okay. D by F. So for this, just replace W equal to F by W, F by D, F minus D. So this is the equation 1 and this is the equation 2. Just replace W equal to F minus D here. So if you put this here, I'm changing the color of pen. F into xf equal to d into xt plus f minus d into xw. So if you solve, you will get dyf equal to, just tell me what you are getting after solving dyf. You are getting xf minus xw by xd minus xw. Yes or no? Yes or no, you are getting or not? Yes, clearly clear. Somalia, you are getting this xf minus xw by xd minus xw. Just have to see that whether negative sign or positive sign. Okay. No problem. I will have to solve this. So f into xf equal to d into xt plus, in place of w we can write f minus d into xw. So here f into xf equal to d into xd plus f into xw minus d into xw. So here f equal to xf minus xw. If you do this here, and d into xt minus xt minus xw. So here d by f will be xd minus xw by xf minus xw. Is it clear? Is it correct or wrong? Just tell me. Wrong, sir. Okay. Okay. Yes. I have written the reciprocal list. Okay, no problem. Okay. Yes. We'll just do here. It will be yes. Where I have written xw minus xf, xw minus xf by so I'm asking, is it correct or wrong? Just tell me. D by f equal to xf minus xw by xt minus xw. Is it correct or wrong? Correct. Okay. Write this. So d by f, just try to substitute. We'll get the value d by f equal to xf minus xw by xt minus xw. So this is for same case. If you do for the undersized particle, means for B, if you apply the material balance for undersize, just apply the material balance for undersize. Hmm. Hmm. In the derivation, if you bring out the negative sign, this will be the same. Okay, okay, no problem. So apply the material variance for undersize, means for B. Applying just XW will be first in denominator and numerator. Ah, yeah, yeah. Yes, Mukherjee, no problem. Is there any doubt? Yes. Just apply material valence for B. So we'll get F into F into 1 minus XF equal to D into 1 minus, sorry, 1 minus XT plus W into 1 minus XW. So if I do one thing, just divide by F. Okay, divide by F. So it is 1 minus XF equal to D by F into 1 minus XT plus W by F into 1 minus XW. So here we can write W by F into 1 minus XW equal to 1 minus XF minus of D by F into 1 minus XT. Is it yes or no? We can write or not? Is it clear to all of you? There are two methods to solve this. One, we can write this F into 1 minus XF D into 1 minus XT plus W into 1 minus XW and replace D equal to F minus W. One way. And another way, just divide by F. Okay. And here we're getting the value of here is D by F. Just substitute the value of D by F here, what we got from the previous, and we will get the value of W by F. Yes or no? So W by F equal to 1 minus XF by 1 minus XW. If you divide this, D by F into 1 minus XT by 1 minus XW. So I hope this is clear to all of you. Is it clear? Okay, if you substitute the value of d by f from the previous expression, so we'll get the value of WIF. Can anyone tell me what will the expression of WIF? Is it anyone? XF minus XT, okay, divided by XW minus XT. Good, very good. We can write in this form also. XD minus XF divided by XD minus XW. Yes or no? Is it clear? WIF equal to XT minus XF by XT minus XW. Is it clear? Bolo. Okay. So sometimes in GATE exam, how? Someone is saying how. So for this, we need to substitute the value of DYF from previous expression. So there is some calculation. Ranjani, did you understand this? Just substitute the value of DYF from previous expression, then we will get this value. There is some calculation. Okay, so I have directly write this. So WIF equal to, substitute this value, substitute DYF from previous concept. So we will get WYF equal to, so what is the difference here? Anyone in between DYF and WYF? Is there any difference? Is it right or wrong? Just tell me, WYF is clear or not? I'm asking from everyone, is it clear to all of you? WYF, the expressions for WYF equal to XT minus XF by XT minus XW. Is it clear? So, okay, so sometimes in GATE exam, they will ask what is the value of WIF. So you can use that formula. You can use this formula. Okay. And sometimes they ask DYF. Okay. So please note down this. So this is all about screening analysis. Yes, sir. In numerator for DYF, we have XF minus XW and for numerator for WYF, we have XF minus XT. Yes. And the denominator is numerically equal. Yes, very good, Somalia. So they asked the question, calculate the value of DYF and WYF for in GATE exam. So in GATE exam, for the GATE exam, you have to remember the value of WYF and DYF expressions, because you can derive in the exam also, but it will kill time. So it is better to remember the expressions for WYF and DYF. So I hope this is clear to all of you. Is it clear to all of you? Yes or no? Someone's are leaving the classes. Please don't leave the class, because this is an important topic. So one last thing in screening, capacity of screen. So please note down this, or if you already noted, just inform me so that I'll move to the next slide. No, 1 minute, sir. Okay, just right. Don't leave the class because many of them are leaving the class. Why? I don't know. Are you understanding or not? I'm asking from everyone. You're understanding or not? Yes, sir. Okay. No problem. Just write this. We'll solve one question. Just try to write this. Or if you are noted, just inform. Please note down this. Or if you are already noted, just tell me. Can I move to the next slide? Just tell me. Can I move to the next slide? Yes or no? Okay. You already created six number of slides. No problem. So, right. Last part related to the screening, capacity of screen, capacity of screen. So what is capacity of a screen? It is measured by mass of material fed per unit area of the screen per unit time. That's right. It is measured by mass of the material fed per unit area of the screen per unit area of the screen per unit time per unit time. This is the capacity of the screen. So can anyone tell me what is the relationship between capacity and effectiveness? If you see the definition for the capacity, capacity is measured by mass of the material fed per unit area of the screen per unit time. So what is the relationship between capacity and effectiveness? Yes, very good, Kushal Narottam. Both are opposite to each other. So you can write, yes, sir, effectiveness is extent of separation. So yes, yes. But if you see mathematically, means logically, the capacity is inversely proportional to the effectiveness. Yes or no? So capacity is inversely proportional to the effectiveness. Both are opposite. Both are opposite factors. Both are opposite factors. So to obtain the maximum effectiveness, the capacity will be minimum. In order to obtain maximum effectiveness, capacity must be minimum. Is it clear, all of you? Capacity must be minimum. So see definition. Capacity means mass of material fed per unit area of the screen per unit time. It is irrespective of oversize and undersize. But effectiveness depends upon oversize and undersize. Na? If the if in whole materials in a material mixtures, if it is whole materials means if it is a mixture of oversize and undersize, so obviously oversize more oversized materials are there. Suppose if there are more oversized materials are there present in the mixture, so obviously oversized mixtures oversized material will retain on the screen. Yes or no? It will be difficult for the oversized material to pass from the screen. So obviously these two are opposite factors. If you see the logical, if you correlate with logically, because capacity means the mass of material fed per unit area per unit area of the screen per unit time. It is irrespective of oversize and undersize, but effectiveness depends upon oversize and undersize. Is it clear? So Malia Mukherjee, I am asking from everyone, is it clear to all of you? So I hope this is clear to all of you. So this is the all things which are related to the screen and screening operations. Okay. So now we try to solve one questions. Try to solve these questions. So this is a gate question, already came in gate 2 and 2. So please note down this, or if you already noted, just tell me so that I'll move to the next slide. Someone is saying something. Long ago problem in gate. Okay, huh? Yes, but this may come in exam. What is happening in gate nowadays? In gate exam, from last 3 to 4 years, basically they are repeating the concept of 90s questions. It is now you can see the paper, question paper. If you see, they're basically repeating the questions of one means they are repeating the concept of 1990 to 2005. They're already repeating the concepts from that topic, means earlier questions nowadays. Basically 60% questions asked from their part, means concept based questions basically asked from in this part, 1990 to 2005. And in GATE 2017, if you see the GATE 2017 paper, it is the easiest question paper in the history of GATE exam. Yes, and if you see the GATE 2015 questions, this is set up by Kanpur, IIT Kanpur, and this is set up by IIT Roorkee. This is Kanpur. Okay, so if you see the GATE 2015 questions, this is the most toughest question paper in the history of GATE exam. Because IIT Kanpur set the question paper based on research analysis, and they asked the questions IIT Roorkee based on numerical analysis. But in GATE 2020-22, the question paper will be set up by IIT Kharagpur, so obviously it will be logical question. See the question paper of GATE 2014. This is also set up by IIT Kharagpur. So those who are giving the GATE exam next year, so definitely go through the previous year question paper from 92 2020-2021. So try to solve one question. So question is, a sand mixture was screened through. A sand mixture is screened through a standard plain mesh screen. The mass fraction of the oversize material the mass fraction of the oversize material in feed, overflow and underflow are were found to be 0.38, 0.79 and 0.22 respectively. Find screen effectiveness find screen effectiveness find screen effectiveness based on oversize. Yes, this is gate to in two question, two marks questions. Screen A sand mixture is screened through a standard 10 mesh screen. The mass fraction of oversized material in the feed, overflow and underflow were found to be 0.38, 0.79 and 0.22 respectively. The screen effectiveness based on oversize. So it is MCQ question. They've given the option, giving the so 0.5, option B 0.58, option C 0.68, option D 0.62. So tell me which is the correct option for this. So this is 2 marks question. If you know the formula, if you know the concept, this can be easily solved. So its answer will be, many of them are giving the answer. Yes, it's negative marking 2. So its answer will be 0.58. Very good, Somalia and Narottam. Yes, option B is the correct answer for this. If MCQ, if their options are given in the question, obviously it will be negative type. If obviously there will be a negative marking. If options are not given in the question, if it is NAT type, means numerical answer type, then there will be no negative marking. Or if the question is MSQ, multiple selective question, then there will be no negative marking. Okay, but also there is no partial marking also. No partial marking for MSQ. Okay. Yes, its option answer will be 0.5835. So option B is the correct answer for this. Solve this question. It is very easy question. So what is the formula for screen effectiveness based on oversize? I think it is D by F into XT by XF. Yes, 0.58 is the right answer. Option B is the correct. This is the formula. So did you note down this question? Did you note down this question? Just tell me, did you note down this question? Yes, okay. So just I'm solving here. Okay. Hmm, 0.58 is the right answer. Do material balance F equal to D plus W. This is the formula for AD into XT, W into F and F, D into XD by F into XF. So F equal to D plus W. So it is 0.38 F equal to 0.79 D plus 0.22 W. So if you solve this, it will be 0.38 F and need to substitute the value of W equal to D minus F and W equal to F minus D. So it is 0.79 D plus 0.22. So obviously it is F minus D. So If you solve, you will get d by f equal to, here you will get 16 by 17, sorry, 16 by 57. Yes or no? If you solve this, we'll get d by f equal to 16 by 57, and we have corresponding its x value and xf value. Just multiply. So just substitute the value of d by f here and xt and xf here. So EA equal to d by f is 16 by 57 into xt is what? 0.79, and what is xf? It is 0.38. So if you solve, you will get the value 0.5835. So obviously option B is the correct answer for this. Now it is clear to all of you. Is it clear or not? So now I'm going to sum up the class. So I hope this question is clear to all of you. So, so what is the summary for the class? Today's class. So we can write the summary. So what we studied today, basically screening. So, so write the basic notes on screening. AI by AI plus 1 from tailored standard screen. It is root 2. So obviously it is Li by Li plus 1. It is AI by AI plus 1 is 2. And this is, and 3 is, yes, Li by Li plus 1 is root 2. No problem. AI by AI plus means area to the next screen area. So it is 2. Yes. So EA is what? D into xt by xf. Similarly, EB is what? W by f into 1 minus xw into 1 minus xf. And fourth one, effectiveness equal to total effectiveness equal to EA into EB. The fifth one is capacity is inversely proportional to the effectiveness. And the sixth one, sometimes they ask the value of d by f. So d by f equal to xf minus xw divided by xt minus xw. The last w by f, they asked sometimes the question, what is w by f? It is xt minus xf by xt minus xw. Please note down this. This is all about today's class. Mostly we discussed screening and total specific surface area. So I hope this is clear to all of you. Or is there any doubt? You can now ask me. Is it clear to all of you? So these are some important points. Directly ask the questions from Taylor standard screen. So I'm asking from everyone, is it clear to all of you? Yes or no? So that's all for today's class. Okay, that's all for today's class. So we will discuss tomorrow the size reduction and laws of size reduction and communication law, and we solve the many types of questions in that. Okay. So I hope everything is cleared now, or is there any doubt? You can ask me. That's all for today's class. So, okay, remember this summary. Okay, so this is very important. They directly ask the question from DYF and WYF. So thank you, all of you. Thank you to all, and good night. So if you don't have if you don't have any doubt, now you can leave the class. Someone is asking something. Sir, in mechanical option, do we have the agitation mixing part to be covered in the fluid? So I'm asking one thing, Somalia. Your already fluid mechanics is going on, okay? So they taught the mixing part. I'm asking from you. They taught the mixing part, mixing or agitation, power number something. They taught. Actually, it is a part of mechanical operation that I'm asking from you. Hello. Yes, sir. It is. Yes, sir. Static is going on right now. No, sir. It is again in cover. Okay. So obviously, I will teach you the agitation in mixing and the concept of power number in laminar and turbulent flow. And I hope they will teach the faculty will teach the terminal setting velocity, hinder setting velocity, all things this. Okay. Mostly I will cover the mechanical operation part. Okay. I will teach you, no problem. Agitation mixing part I will teach you. So thank you all of you. Is it clear, Somalia? Because in GATE exam, the question is coming from the mixing part also. Fraud number, power number concepts are there. I will teach you, no problem. So that's all for today's class. Thank you all of you. Now we can leave the class.